Your research is about developing biomedical devices for rehabilitation.
Right.
Tell me about it.
Sorry. Okay. Yes, it's about developing biomedical sensors for rehabilitating patients who are suffering from hip fractures. So mostly the problem is that you need to exercise after your hip fracture so that you get a faster rehabilitation rate. So when you do exercise, you never know what is the right pattern you have to exercise, what is the right load bearing you have to apply. So this is because you don't have any proper feedback system. So I am involved in the development of a sensor that could provide that feedback, which is very crucial in faster rehabilitation, and millions of people would be benefited from that.
So what your research contribute to is to find better ways to rehabilitate patients with hip fractures.
This will definitely help in better rehabilitation with giving proper feedback. So
is it also an economical angle?
it is very economical in that respect, because otherwise feedback can be obtained from CT or X-ray, which is expensive, first of all, and the second thing is that it's harmful because of the ionizing radiations. But what we use is microwave signals, which are not ionizing, and we could use very cheap, sorry to say cheap, but it's low cost, cost-effective equipments for that, and also it can be real time.
So I mean, low cost rehabilitation, it sounds to me like more people around the world in poorer countries can also get benefit of this.
Exactly. Primarily we are developing something for Europe, but this could be also used in developing countries as well, where you have no access to expert medical advices and stuff.
So your research can hopefully fulfill at least 2 or 3 of the 17 global goals that United Nations has for a global sustainable world.
Definitely. So it's not only for elderly, but also for infants. We in Uppsala Hospital, we are working with infants having craniosynostosis, premature fusing of their skulls. So the skull plates would be removed so that they have enough space for the brain to grow. But the problem there is that you don't have any frequent monitoring of the bone growth, which you could definitely do using these sensors, which is much safer, and it can be done on kids. We have ethical approval for that. So
how far is it from practical use?
Right, exactly. So we have been working on this project for 1 year. So 10 patients are already included, and the results are so promising. So we expect like in 2 to 3 years time span, we could make a reliable product based on this technique.
How does it feel working with this?
It's awesome. It's really fantastic working with that, because you work for a cause. So that gives you a lot of satisfaction. Yes.
Great. Thank you very much.